Hi guys, welcome to Pre-Calc 11, Chapter 1.4, Geometric Series. We just finished off geometric sequences and now we're just moving on to the PLOs for geometric series. The first rule is to derive a rule to determine the sum of n terms in a geometric series. We want to know all the different variables for the general term formula in a geometric series. We want to solve word problems. And don't worry about the last one. First, let's find out what a geometric series is. It's basically the sum of all the terms in a geometric sequence. We did geometric sequence last time. It's where you multiply the same number each time. As you can see in this sequence, we multiply 3 each time to get to the next term. The only difference is you put the addition sign and you want to find the sum of all those terms. We have two more annoying formulas to remember. First one is S of n equals t1 and then in brackets r to the power of n, all of it divided by r minus 1, or the second term is S of n again, is equal to r times t to the power of n subtract t1, all of it divided by r minus 1. I'll go over the specific bits of each formula. S of n is the total sum of the whole equation. T1 is the first term of the sequence. For this example, it'll be 2. R is the number you multiply by each time or divide by each time. For this example, it'll be 3 because you multiply by 3 each time. N is the number of terms in the sequence. And yeah, R we did already. And for this specific equation, T of n is the last term in the sequence. So if you're given the last term, you should use that formula. Let's go to the first question. It shows 6, 9, 13.5. So let's find out the ratio first. To get from 6 to 9, you have to multiply by 1.5. To get from 9 to 13.5, you have to multiply by 1.5. So that'll be our ratio. And the question is they've asked us to find the sum of the first 10 terms. Since we don't know the last term, we cannot use this formula. So this is cancelled out. Let's use this formula right here. So let's start filling in the blanks. We know that it's the sum of the first 10 terms, so we can put 10 for all the n's. We know that the first term in this sequence is 6, and we know that the ratio is 1.5. After you crunch all the numbers together, you get a final answer of 680. Moving on to question 2. In this question, we know that the first term is 12. We know that the ratio is 2, which means you multiply by 2 each time, and we know that there are 10. They want us to find the sum of the first 10 terms. So again, we don't know what the last term is, so use the first equation and then fill in the numbers. We want to find out first 10 terms. We know that the ratio is 2, so we fill that in for r, and we know that the first term is 12. So multiply all those numbers together and divide as well, and you get a final answer of 12,276 for the sum of the first 10 numbers in the sequence. This time the ratio, we have to find out the ratio. To get from 27 to 9, you have to multiply by a third or divide by 3. To get from 9 to 3, you have to multiply by a third or divide by 3. And this time they want us to find the sum of the sequence all the way to 1 over 243. So we figured out a ratio, that's 1/3. So since we know our last term, we can use the second formula this time. So let's fill in the numbers. We know that the ratio is 1/3, so 1/3 times the last term, which is 1 over 243. Subtract our first term, which is 27. All over the ratio, which is again 1/3, subtract 1. So you get negative 26.9986 all over negative 2/3 for a final answer of 40.5 as the sum of the terms. But the problem in this question is you don't know how many terms this is. You just know that the sum is 40.5. But you want to find out how many terms it is so you can write that in the final answer. To find what term it is, you have to use the equation from the previous section 1.3 to find out what term this is. You don't know what that is yet. So if you use the formula T of n equals T1 times r to the power of n minus 1, we just fill in the information. So the Tn we're looking for is 1 over 243. That's what we're looking for. And we know the first term is 27, and the ratio is a third. So when the first thing we have to do is solve for n. So get rid of all the other things. So divide by 27 on both sides. You get an answer of 1 over 6561 is equal to 1 to the power of 1/3 to the power of n minus 1. And then if you expand that, that's what it equals. So as we move on here, we know that 3 to the power of n minus 1 has to equal 6561. So we can guess and check to find out which power equals 6561. If you do 3 to the power of 6, that gives us 729. That's too small. If you do 3 to the power of 10, that gives us a really, really large number. We don't want that. But if we do 3 to the power of 8, it gives us 6561. That's what we want. But remember that it's 3 to the power of n minus 1. So if n minus 1 equals 8, n equals 9, which means it's 9 terms. So the final answer is sum of 9 terms gives us 40.5. And the last first word problem, then that'll be our last one. Someone is trying to run a marathon. The first week she runs 25 kilometers and then increases her distance by 10% each week. So that's how the situation is modeled. And she wants to do it for 15 weeks. So how far will she run in the total time? So let's use this formula right here, since we don't know how much she runs in the last. Since we don't know the last term, we'll use this first formula. We know it's the sum for the first 15 weeks. What is the first term? It's 25 because she runs 25 kilometers in her first week. We know now the ratio is a little bit tricky because she runs 10% more. It'll actually be the 100% plus your 10%, so it'll be 1.1, not just 0.1. And then so that'll be at ratio 1.1, and then 15 again for the number of weeks. And then once you do all the math, you get a final answer of 794.3 kilometers that she has run. So that's just the geometric series. I hope that was helpful. Thank you.